right, so we're finishing up Chapter 10 today, and I told you I'd tell you the good news. You won't be asked to do this on the AP test. I said often because I can never guarantee what's going to show up, but I have never seen a student be asked to come up with a transformation on the AP exam. So last time when I went through this process of trying a log and then trying a square root, you most likely would not be asked to do that on the AP test. It takes way too long, and it is rather subjective. There's a little bit of personal preference in which model looks the best. So instead on the AP test, you might be asked to do some of these other things. For example, you might be asked to say what's wrong with the analysis. I'm thinking you're looking at a scatter plot or a residual plot. So you're looking at graphs and you're commenting, right? Oh, well, this linear regression is not appropriate because the scatter plot is curved. Or this linear regression is not appropriate because the residual plot shows some shape. So that could certainly happen. You might, and I'll show you an example of this, use computer output to identify the best choice for a model. I'd give you some different graphs, and you have to say, well, we should do this one because. And you'll also be asked to use computer output to maybe write an equation, right, to write your equation of the line, and to make some predictions, which can be just a little bit more complicated because we have that transformation in there. So this particular story problem is actually from your textbook, and I just tweaked it just a little bit. But there was a scientist, Robert Boyle, and he examined the relationship between the volume in which a gas is contained and the pressure in that container. He used a cylindrical container with a movable top that could be raised or lowered to change the volume. He measured the height in inches by counting equally spaced marks on the cylinder and measured the pressure in inches of mercury as in a barometer. And, you know, I don't know a ton about science, so I'll just take them at their word that that would work. And the data is actually listed in your textbook. I believe this is page 240. So what I've done is I've actually provided you, we're going to create an appropriate model, provided you two different graphs. On this first graph, we have pressure and volume. So you'll notice the height is here on the x-axis, and the y-axis is giving us the pressure. Hopefully you're noticing that this is not a linear model. There is definitely a pronounced curve there. So this is not linear. So a model created here would not be appropriate to use our linear regression. But on the other side, we have the height again, and then 1 over pressure, they call that the reciprocal, right? 1 over pressure. And hopefully you'll notice this looks, wow, very linear. So I might simply ask you to defend that the reciprocal model is better because the scatter plot shows a linear relationship. So that's what I mean when I say use some provided graphs to just identify which model is the most appropriate. All right, so I've also provided some computer output so that we could create an equation based on this model. So just to remind you, we had two variables, and we can see that here. Right, we have the height on the x-axis and 1 over pressure on the y-axis. And then you'll notice here where it says dependent variable, it has reciprocal pressure. So make sure when you write an equation based on a transform model that you use that new y variable. So I'm going to have 1 over pressure. That's my y variable equals. Now I need my y-intercept. Remember, that's my constant. You're real careful to watch out for that scientific notation. So I have a negative 0.000007. I'll just round that off to 77. Okay, plus, again, for my height, here's my coefficient, so that's my slope. Watch out for scientific notation. 71. And again, I'm just rounding these off a little bit. Times the height. And of course, I would still include a hat to indicate this as predicted reciprocal pressure. And that's my model, so I can still do the same thing. I can actually make predictions using this model. So what pressure would we get if the height was 30? Well, I'm going to go ahead and plug it in. I predict that 1 over the pressure would be equal to negative 4077 plus 0.0071 times 30. All right, so if I plug that in my calculator, I get that I think, or I predict, that 1 over the pressure, keep that hat there, is 0.021. Again, I'm rounding that just a little bit. There's only one problem. I didn't ask what 1 over pressure would be. I asked what would the pressure be. So I actually have to transform this back. So here's where our algebra skills come in. This is why Algebra 2 is a prerequisite for this class. Okay, I'm going to ignore the hat for just a minute. I have 1 over pressure equals 0.021. I'll put it over 1 so that we have 2 fractions here. There's a variety of ways you could solve this. A lot of people like to cross multiply. Some people know that when we cross multiply, that's really the same as just rewriting this upside down. So I'm just going to take the reciprocal of each side. Pressure over 1 equals 1 over 0.021. Again, if you'd like me to show the cross multiply, please let me know. I'd be happy to do that. So it looks like my pressure is going to be 1 over 0.021. So I just put that in my calculator, 1 over 0.021. And I find, so this tells me that the pressure over 1, that's the same as pressure, equals 47.62 if I round that off. And I did take that hat off, so I'll put it back on. Our predicted pressure is 47.62, and I'm not sure what they measured in. I think they said inches of mercury. So that is my prediction. So the thing to watch out for is you'll need to do a little bit of algebra to solve for the original y variable. All right, you could stop here. I'll go ahead and show a quick cross multiplication for those who need some review on their algebra. Let's do this in maybe green. Okay, 1 over pressure equals 0.021 over 1. Remember, when we cross multiply, we simply multiply on the diagonal. 1 times 1 is 1. That's equal to multiplying the other way. Pressure times 0.021 is simply 0.021 times the pressure. Remember, I'm solving for pressure. That's a variable. Maybe call it P if that makes you more comfortable. So if I need pressure alone, this thing right here, that means I need to get rid of that 0.021. It's being multiplied, so I would divide to get rid of that. And that's how we ended up right where we saw previously. Pressure equals 1 over 0.021. That's where I started. That's where I got right here. So there's a quick review of your cross multiplication.